Hello good people, I'm going to talk about ionic and covalent bonds. As the names suggest, ionic bonds will be present in ionic compounds, while covalent bonds will be present in covalent compounds. The pairing up of various atoms is very wholesome and for the most part PG rated. But how do we know about their individual kinks and which atoms will do what? And can we use the periodic table to help us? In a neutral atom, the charges are balanced. The number of protons is the same as the number of electrons. However, that does not mean that the atom is stable. Recall that atoms are stable when all their valence electrons are paired up. In order to achieve that stability, metals will donate their electrons, while non-metals will accept electrons. This brings us neatly to the concept of ions. Ions are charged particles. They are atoms, or even groups of atoms, where the number of protons does not equal the number of electrons. Let's have a look at sodium. Sodium in its ground state has 11 protons and 11 electrons. Overall, it is neutral, as the number of positively charged subatomic particles is the same as the number of negatively charged subatomic particles. However, it is not stable, as it has an unpaired valence electron. Sodium is a metal and will therefore donate this electron. When it does that, we will end up with a sodium atom that has 11 protons but only 10 electrons. It has one more positive charge than it has negative charges. And so we say that this sodium is one positive. Once an atom has a charge, we refer to it as an ion. And if that charge is positive, we refer to it as a cation. We could say that we have started with a sodium atom that has lost an electron to become a sodium cation. Now, let's look at chlorine. In its ground state, chlorine has 17 protons and 17 electrons. It is neutral. However, it is not stable, as it has an unpaired valence electron. As a nonmetal, it will accept an electron. Maybe it will accept the electron that the sodium atom has donated. When it does that, we will end up with a chlorine atom that has 17 protons and 18 electrons. It has one more negative charge than it has positive charges, and so we say that the chlorine is one negative. An ion with a negative charge is referred to as an anion, not an onion. Note that when nonmetals become anions, there is a slight name change, and the suffix "ide" is added. So, chlorine atom has become chloride anion. Ions are more stable than the atoms from which they came from, but there is more to it. Oppositely charged ions attract, and so this positively charged sodium cation will be attracted to this negatively charged chloride anion. As a result, we will end up with sodium chloride, a compound made of ions, and thus it is an ionic compound. The attraction between oppositely charged ions is referred to as an ionic bond. We can use the periodic table of elements to predict what sort of ions we will end up with. It is linked to the valency of the atoms. Recall that the valency of an atom refers to the number of unpaired valence electrons. Charge of the resulting ions is connected to this. And once again, there is a neat pattern. All elements in group 1 will end up with a 1 positive charge. Those in group 2 will give ions with a 2 positive charge. Those in group 13 will give ions with a 3 positive charge. And the ones in group 14 will end up with a charge of 4 that can be positive or negative. They swing both ways. After group 14, we start to go backwards. All elements in group 15 will give an anion with a 3 negative charge. Then in group 16, we will end up with anions with a 2 negative charge. In group 17, we will end up with anions with a 1 negative charge. Noble gases have a valency of 0, therefore no electrons will be donated or accepted, and so their charge will remain 0. They will not form ions. Let me go through one more example of this. Calcium is a group 2 metal. It will donate or lose 2 electrons, giving us a calcium cation with a 2 positive charge. In case of oxygen, as a group 16 element, it will accept 2 electrons, and we will end up with an oxide anion with a 2 negative charge. Combining these two, we will end up with calcium oxide. Note that while ions are charged, ionic compounds are not. Overall, ionic compounds are neutral. Most of compounds in biology are made from non-metals only. If we are dealing with non-metals only, the unpaired valence electrons are shared rather than donated or accepted. Let me explore what happens when an atom of hydrogen is combined with an atom of chlorine. Both hydrogen and chlorine have a valency of 1. They have 1 unpaired electron. This also means that each one of them is capable of forming 1 bond. If the mood is good and the right kind of music is playing, we will end up with a happy pair. From the point of view of both atoms, all their valence electrons are paired. This is a stable electron configuration for both of them. They will remain together, at least until something better comes along or the conditions change. This shared pair of electrons is represented by a line between two nonmetals. It indicates a covalent bond. The electrons that are not involved in the covalent bond are referred to as non-bonding or lone pairs. Depending on the situation, they might not be drawn in at all. Whenever we combine nonmetals, we end up with covalent compounds. The number of unpaired valence electrons tells us how many bonds a nonmetal is likely to form. The pattern for this is given by the valency of the atom. So from left to right, we have 1, 2, 3, 4, and then we start going back 3, 2, 1, and 0. Once again, noble gases are not going to form any bonds because all of their electrons are already paired up. There are a couple of atoms that we really need to be comfortable with when it comes to how many bonds they can form. As far as we are concerned, hydrogen and all of the halogens can only ever form 1 bond. Oxygen will form 2 bonds, nitrogen will form 3 bonds, and carbon will form 4 bonds. Let me explore a few more examples. Up here we have hydrogen and oxygen. Oxygen has a valency of 2, which means it can form 2 bonds. Hydrogen has a valency of 1, which means it can only form 1 bond. So if we bring this hydrogen here, great, it is happy, but the oxygen is not happy. It still has 1 unpaired valence electron. To fix that, we are going to introduce another hydrogen atom with its valence electron. And now everybody is happy. All of the valence electrons are paired up. The shared electrons are now the covalent bonds that we represent with a straight line between the atoms. And we have ended up with H2O, water. What about nitrogen and hydrogen? Once again, hydrogen has a valency of 1, nitrogen has a valency of 3, therefore it wants to form 3 bonds. If I bring this hydrogen over, great, it is happy, but the nitrogen is not happy. We need 2 more hydrogens, so let me quickly draw them in. Once more, the shared electrons become the covalent bonds that we represent with straight lines. And now we have NH3 or ammonia. A similar story will play out with carbon. Carbon has a valency of 4 and therefore wants to form 4 covalent bonds, which means I need to have 4 hydrogens in total. Let me quickly draw in the other 3. The 4 shared pairs will end up being 4 covalent bonds. And now we have CH4 or methane. Note that so far I have shown only single covalent bonds. Nonmetals such as oxygen, nitrogen and carbon are capable of forming double and triple bonds. Let me quickly have a look at that too. Oxygen can form single bonds such as we have in water, but it can also form double covalent bonds that we see in molecular oxygen. This is the oxygen that we breathe in. Nitrogen is capable of single bonds, such as the ones in ammonia. However, it can also form double and a single bond, as is the case of nitrosyl chloride, a poisonous gas. And it can form a triple covalent bond that we have in molecular nitrogen that makes up about 70% of the Earth's atmosphere. Carbon can form single bonds that we have seen in methane, a gas produced by many bacteria, but it can also form a double and 2 single bonds, as is the case in formaldehyde that can be used as an antiseptic or a preservative. And finally, carbon can form a single Na triple bond, as is the case in hydrogen cyanide. It is a well-known poison that is used as a fumigant. As a bit of a vocabulary side note, the word covalent comes from the combination of two Latin words. We have the prefix co, which stands for together or jointly, and the word valentia, which means strength or capacity. So we could say that the valence electrons represent the capacity of an atom to cooperate with other atoms and form covalent bonds. I know, at this stage some of you are having so much fun that you are sliding off your seat. However, there will be those who have reached their own capacity to listen to me. That is all for now, and I will see you on the flip side.